Analyzers. Welcome to your Chapter 10, Lesson 5 notes, all about horizontal shifts of your sinusoidal functions. These are also known as phase shifts. These are the things I've kind of left for last out of all of the movements that your sinusoidal graph can go through, right? Your amplitude, we stretch it out or make it smaller. Our period, we can stretch that out, stretch the graph out this way, or shrink it closer, right? Make it like real quick, close together. The vertical shift, move it up and down, which also moves up and down the midline. But the phase shift moves us away from the y-axis for our start of our typical period. Okay, so normally, for example, a sine function would start down here at 0, 0. But when it comes to a phase shift, your sine function is going to start in C places like this. Okay. And when it comes to, being inside parentheses like that, it's always the opposite of what you think, right? So if you've got an x minus C, that's when you move to the right C. And if you've got an x plus C, that's when you move to the left C. Now, the nice thing is because both of these are, infinite cycles that are occurring, once you've figured out where things should be, you can continue that cycle going through. Okay, so this is the one that throws people the most, the phase shift, because it really is new, but it's still just a left or right movement. Okay, we just call it something a little bit different than we used to call it. Before we just called it left and right. Now it's called a phase shift. So we're just going to start and end in different spots and then kind of go backwards to get back to the y-axis. Okay, so here, remember, you're going to want to have we usually call this the B value. Okay, we're going to want to have the B value factored out of this spot. Okay, so if these are all like GCF'd together, then we're going to want to bring that B value out and deal with it that way. It makes things a lot easier for us. Okay, so let me just show you a phase shift going to the right 45 degrees. Okay, so down here is a picture of a phase shift, of a horizontal shift. Normally, my cosine curve would be starting here. Okay, so this is the red one, is the normal. Okay, it starts here all the way up to positive 1, back down to 0 at 180 degrees or pi radians, back down to negative 1 at 270 degrees or 3 pi over 2 radians, and then up to 0 again, showing you the cycle of sine. If I scooch this over 45 degrees or pi over 4 radians and start it from there, notice all these pieces are the same. They're just all switched over just a little bit to the right, just 45 degrees to the right. That's it. That's what a phase shift is, scooching things over to the right or to the left. Okay, and again, because they're infinite cycles, once you know that starting place, you can still do the same deal. Okay, so obviously we didn't make it all the way back, right? So this is all the way back. So we've still got one full period of sine there, one full cycle of sine. Okay, and that's what we're looking at doing here. So these aren't everyone's favorites. And in fact, if we move sine and cosine a certain way, all of a sudden they're actually right over each other. That's why we call these the sinusoidal graphs, because they're only a little bit apart from being exactly the same curve. And we will see that momentarily. Okay, so let's first start by talking about what if I do have a value multiplied by my x in the equation. I've got to factor out that value as a GCF. I need to make sure I don't still have a number in front of x. So I've got to have the b separate from the phase shift, okay, so that I can interpret each of those. So up here, I'm just kind of reiterating that fact, and I know I had kind of said that to you guys already. Okay, I had kind of said that. But let's actually practice that. So now we've got a 2 in front of the x. That's got to come forward, and then divide each thing by 2. Now you've got x minus 4 left here. Okay? That's what we're looking at going on here. That tells me x cannot have a coefficient, right? So x has got to be a 1 in front of our x. Okay? What this tells me right here is that my phase shift is to the right 4. So my B value here is 2, and my phase shift is my C value, and we're going to the right 4 because it's technically the opposite sign. So it's going right. Okay? Here, I know they didn't ask me for B, by the way. I just want to make sure you know that's what this GCF thing is. That's going to be your B value. How many, that's your frequency. How many sine cycles are we going to have between 0 and 2 pi? All right, anyway, continuing. So here we have a 4 in front. We're going to have to GCF up the 4. And now, well, over here, that means you need to divide this by 4, okay? Because you're dividing each of these things by 4. Sure, x is alone right here as a 1x. That's fine. That's what we're supposed to get. But that does mean you've pulled a little bit extra out of here. And negative 2 divided by 4, this is a negative 1/2 pi, or a negative pi over 2. What that tells me is that my B value is 4. So I have a frequency of 4 cosine curves between 0 and 2 pi. And then this is my phase shift to the right. So we're going to go right 90 degrees, or pi over 2 radians. I'm just going to put 90 degrees right here. These are obviously easier to deal with when it comes to a real sine and cosine coordinate plane, because going right for, I don't know, that's going to really confuse me on a unit circle, right? Our unit circles are in degrees or radians, so this will make more sense to actually graph when you see these. So I know they sound a little confusing, but really that's what you want when you go to graph the sine and the cosine functions. All right, last one. And this will be a doozy because you're going to have to divide a pi over 3 up front. So the pi over 3 has to come out, right? Leaving you with an x plus whatever 2 divided by pi over 3 is. So over here in our margins, right, let's just take this pi over 3, and we're dividing it out of 2, right? So 2 gets divided by pi over 3. Oh boy. Okay. So why don't we first multiply top and bottom by 3? Okay. So that this 3 is gone. You get 6 over pi. Well, you can't be over pi. So now let's, trying to rationalize, right? So when we look at this guy, oh my gosh. Well, this is why. I should have 6 pi over here, right? I'm going to say there should be a pi when we're talking radians, right? So now we've got these guys left. They cancel each other out. No more pi on the bottom. Okay, you've got 6 that's left right here. So that tells me that when I take my B value is pi over 3. So that's how much of the sine curve I fit. I only fit pi over 3 of the sine curve. We don't have to graph this. And then I go left. So my C tells me I'm going left 6 on the other direction in the y-axis. And again, I'm not going to make you graph this. It's more dealing with the numbers of this. So, don't forget a pi when you're throwing a radian up there and dividing by pi over 3. So again, it's more of you're probably going to want that C term to be a radian measure when you're going to graph these things. So I started you with one that just has a phase shift in it. Okay, there's nothing else going on in exercise 2 except the phase shift. We're going to shift the entire sine graph to the right pi over 2, or 90 degrees. Okay, so my A, my amplitude is still 1. My C is pi over 2, which means I'm going to go right pi over 2 places, which is 90 degrees. My D value is 0 because there's nothing added or subtracted at the end, which means my midline is still y equals 0. So that's good. This guy right here, the x-axis is still my midline. Means my max is 1 and my min is -1. Still good. Okay, so now remember that my frequency is my B value. Well, I didn't have anything that I had to factor out front, so my frequency is 1. So I'm going to have one whole period between 0 and 2 pi. So one whole cycle goes between 0 and 2 pi, okay, because that's my B value. It's 1, and it matches up with my frequency, which means that my period is 2 pi. That's the distance where one full sine curve will occur. Okay. Now I'm going to start over on this side. And I'm going to remember that normally my sine curve starts right here. But this time, I'm supposed to start my sine curve right here. And then I'll go up. I'll make 1 up here and -1 down here. So then I'll go up all the way to the top, back down, and then down here. So this part of my sine curve is shown over here. Okay. Now I can just carry that continuation back. So I know that this will be my minimum over this direction. Okay. Because I had gone in or right pi over 2. That's where my start point went to. And now I just continue heading backwards. So that means that my zeros just kind of made it to the pi over 2s instead. And my maxes ended up at the pi's, and my mins ended up at the 2 pi's. Now head backwards with it. And what does this look like once I get it all on here? While this is a sine graph, this is sine, that has been shifted over 90 degrees. This is a sine graph that's been shifted to the right 90 degrees. Doesn't it look like a cosine that's upside down? Or if you're looking, if you had gone from here to here, that looks like cosine. But if you look from here to here, there's your sine. This is why we call them sinusoidal graphs, because they're just a little bit off from actually being the same graph. If you use this horizontal movement, if you use this, you can actually turn a sine graph right into a cosine graph. Okay? That's what we're looking at doing. I just labeled it at the end. But all this one had was a phase shift. So this one just shows you that phase shift that we were just looking at. Okay? Moving to the right pi over 2 or 90 degrees. So that's just where my first start point went, and I figured every point from then. Keep looking. Okay, here we go. Whoa! Lots going on here. I'm going to factor out the 4 first. That'll be very helpful if I'm factoring out the 4 first. Okay, so let's see. 4 and then x minus, let's see, 2 divided by 4, that's 1/2, right? There we go. So 2 sine 4 times x minus 1/2. And then the 3 back here. Well, okay, so we've got a couple of pieces, right? So let's look at all of our pieces together, step by step. The A value is the number in front of sine, that's 2. So A is 2. The B value is the number we just GCF'd out front, so that's the 4. The C value is the opposite sign of what we got in here, so the C is 1/2. And the D value is that number right there at the end, the 3. Okay. Now remember, this tells me my midline is y equals 3. So that does help me out as far as, oh, okay, that's where I'm going to have my graph being cut in half. So that's good. Actually, let's get that on there, and I'm going to put that in red just so I don't get confused with it for the rest of the graph. So let's count 1, 2, 3. We'll go up 3 here. Okay. And that will be our, there we go, 4, 5, just to get a couple numbers on here. But this is our midline. Okay, there's our midline. Y equals 3. That's our midline. There you go. Okay. Now, next thing, amplitude, right? 2 is my amplitude. So that means I'm heading all the way up to and down to from the midline, okay? So the midline is at 3. Well, up to is going to put me all the way at a max of 5. And down to from here is going to put me at a min of 1. So there's my maximum y value and my minimum y value. So that's good. Okay, so we got another good thing, right? Okay. So now what we're going to do to end up getting ourselves our period is we're going to take the b value and divide 2 pi by it. So since my b value is 4, 2 pi divided by 4 leaves me with, right, 1/2 pi. Oh, this is wrong right here. That's why I'm looking at it. This is pi over 2 should be it, because this should be over 4. So our b value is 4. We had to pull a 4 out from the front. So that's incorrect. So this should be pi over 2 as our b value. All right. And what that means is, this is going to be insane, but an entire cycle is going to fit from 0 to pi over 2 and be all the way up to 2. So from here to here is one full sine. Okay? So that's a little insane, right? Our frequency, right? That's a little insane, but we can do this. And now our C value is 1/2, meaning we start 1/2 over in the x-axis. So that's actually approximately pi over 6, meaning if this is 30, 60, 90, okay, here is your pi over 6 start, or 30 degrees. So this sine starts right here on the 3 is the midline. Now, 90 degrees from this would be right here, which is 2 pi over 3, or 120 degrees. Okay, I'll write that underneath, 120, since this has been in degrees. 30 degrees, 120 degrees, right? So since that's the case, this is where my finish is, right? I just need to recheck my frequency. I don't know why that has a b value of 2. It's 4, because we had to pull a 4 out. Leaves us with 1/2. I mean, you can see it right there. So there it is. And then that's what we plug in down here. So yeah, we still get this pi over 2. All right, I'm just making sure, since I had those kind of incorrect over there, right? So this is my start. I've got to go all the way to, let's see, this says 75 gets me down to my 1. That, let's see, I'm here, back here. That makes sense because from here I go up and then back down what's halfway between 30 and 120, right? Minus 120 is 70. 70 divided by 2. 30 minus 120. 90. 90 divided by 2 is 45. So at my 45, that would be here, I'm all the way up. And then here, I'm all the way down. And so midway, right there. Whew. It took a sec. My amplitude is 2. That's why I'm all the way up here. Then I have to come all the way back down. And then I have to go all the way down to my minimum and back up. And that's one full sine curve from there to there. Because I got to fit one full sine curve in from pi over 2. Yikes. Wow. I got to keep going with that. Okay, let's do that again. Let's find our next. So this is our next 30. And then from here, we're going to get to, all right, what did we bounce? We bounced up 90, right? So 210. So let's bounce up to 210. That would be right here. There's our 210. Okay, so that's where our end point is for this one. All right, our midway right in here, and then our halfway, and our halfway, and then connect. Thank goodness these are sketches, right? That is not a pretty curve down there. There we go. We'll keep going with it. Now I got to get another 90. So what? That gives me to 300. So here's 300 right here. There's 300. So there's my next one. Okay, cool. So now we've got, let's see, midway, and then midway, and midway, and all the way up to, this is nice and big curves there. Lots. Frequency is huge because frequency is 4. The B value is 4. We got to get 4 cycles in here. Whew. Now I'm not going to be able to fit another 90 to 390. So I can only fit what I would typically have, right, in this 30-degree segment. And so if you notice, that's actually going to get me, think about you came in 30 degrees, right? So coming in 30 degrees from here to here is like a typical, because this is halfway, right, is like a typical not all the way down. Ew. So, because here to here is 90, so a third of it. Yuck. So what we want to look at is a third from here to here. So your bottom is in the middle of that, and then you got to keep going. So same this direction is you're going to get the bottom right here, okay? But the top is there, and then you have to go kind of back down this direction, but you're not going to get all the way to the min on this side. So it's like partly to the min, almost to the min, because it cycles back over this way. 1, 2, 3, 4 peaks. So your frequency is 4. You got the 4 in there. It's a sketch. Look at your amplitude. You got your full amplitude in, right? Up 2 and down 2. So you got your full amplitude in, right? We have from 0 to 360, so we fit that whole cycle in, okay? Our D value was 3, so our midline is up here at 3, so that's good. We scooched everything up 3 when we were doing that. Whoa, that was a lot to consider, right? That was a lot we had to consider when we're doing that. And your sketch, by the way, of that is down below. This isn't, as we can tell, a full graph of our sketch. This is a smaller version of it. And the reason is because this is going by 1, 2, 3. We can't fit it all when that's the case. We were going by pi over 6 or 30 degrees. And these were our sections going by 30 degrees. This is not a full 360 graph. This is just showing you each of those movements in a very small amount of space compared to what we went through. Okay. Thankful that I had those points at the bottom correct, even though my B value should have been 4. I got to have 4 of those down there. So that's where those are coming from. We'll work on that together, guys. But make sure you give these a try, okay? And watch the supplemental video as well for this. All right. This is what we're going to do is start moving these graphs around. I'll see you guys very soon with this. Have fun. Oh, by the way, your chapter 10, lesson 5 notes. We'll stop and we'll quiz moving all of our sinusoidal functions around before we get to tangent and really blow your mind.